Basic of the trinomials that you'll have the students factor, because everything here is positive. I have a leading coefficient of 1. All my other terms are positive, so I don't have to think about zero pairs. I don't have to think about adding a positive and a negative. I'm working only in the positive realm at the moment. So when I'm factoring, I want to think about working in an area model. I'm going to create a rectangular area that has to be completely filled in. So I'm going to start with two ends, my x squared and my positive 6. And I'm going to fill in my x's to make the area model. In this case, I'm going to have 2x's up here and 3x's over here to create my model. And then it becomes how you want to name your terms. This distance here is x. I have 1, 2, 3 down here, so I have a positive 3. This distance on this side of the x squared is x. And I have 1, 2 here, so I have a positive 2. So I could call this x plus 3 times x plus 2, or x plus 2 times x plus 3, and I think whatever you decide is how you want the order to be going is how you sit with the students early on, and then it keeps it easier for you to grade so you don't have to look at both models. We're going to factor x squared minus x minus 6. Notice that I have a positive x squared, a negative x, and a negative 6. Thinking about working with this, obviously I don't have enough tiles at the moment to create a new rectangle. So I'm going to have to be adding some zero pairs as I go along with this. When I'm working in the area modeling, numbers like 6 that are composite can be set up as a 2 by 3 area or a 1 by 6. And the students may not always see that as they're going through this. So at some point in time, you're going to want to make sure that you point out that numbers that are composite have multiple ways of being factored. So I may start out and think about it in this way because look, my 1 fits right there, but I'm not done. My problem is I have to fill out this entire thing to make the rectangle. And this is not going to work because I need to be adding zero pairs, and when I'm adding the zero pairs, the positive all have to be together and the negatives all have to be together, and I can't add positive 6 here with my x's, even though it would make a rectangle, because it wouldn't model my problem. So I'm going to rearrange, again, this back to my original problem, my rectangle, and this time I'm going to go 3 across and 2 down. And I want to think a minute about this. I need some positives to be added and some negatives to be added as well. Because this is a negative x, the coefficient here is negative 1, I need more negatives than positives to get my answer, because when I add a negative and a positive together, I take the sign of the one with the larger absolute value, which would be a negative in this case, had to be the larger one. So I'm going to put the one negative 1 that I have already on the side with my 3 x's, or my 3 1's, sorry, to start filling in my model. Then I'm going to add a zero pair, a positive and a negative. I'm going to add the negative on the side with the negative, and the positive will go on the other side. I'm going to add another zero pair to complete the rectangle. So now when I look at my rectangle, I get x plus 2, x being the length of the side, 1 and 2 here, and going across this way, I get x and negative 3, because I have 3 negatives here. And when I look at my factors, I have x minus 3 times x plus 2, or x plus 2 times x minus 3. And if I have the students go back and check, which I would certainly want them to do on this one, I would realize that I get a negative 3x here and a 2x here, which gives me the difference of being a negative x. Looking at this particular one, and I have x squared minus 5x plus 6, so I have my positive, my negatives, and my positives. And because this is a positive number and this is a negative number, I know that I'm going to have to multiply a negative times a negative to get my positive. So I'm going to start out by looking at this one, and I'm going to go with my 6 across, thinking it's a 1 by 6, because I might not have done a problem with a negative before, And that just seems like one that would fit for me. And if I slide these in, I feel like I'm almost there, because if I were to add a zero pair, which I can always add a zero pair, it would give me my rectangle. And I may say that I'm done. The problem, however, is that if I'm multiplying these negatives here times these positive here, I need a negative here. And what I have is a positive. So even though that looks like great, I made my rectangle, I added a zero pair, I followed all the steps I was allowed to follow, my answer is wrong, because a positive times a negative will not give me a positive back. So let me remove that zero pair and start again. Let's do a 2 by 3 down here for my 6. And this time, if I put my 2 here and my 3 here with all the tiles I started with, I have my rectangle. And I have a negative times a negative equaling my positive. So my factors would be x minus 3, 1, 2, 3, and up here x minus 2, and I have x minus 3 times x minus 2 for my area, or x minus 2 times x minus 3, whichever way you want your students to be writing that. Ready?
Mm-hmm.
Okay, when I look at this for my first starter, yikes, I don't have that x squared all by itself anymore. I have 2 of these that I have to work with. And I'm looking at a whole lot of x's here with the 7, and not many 1s with my 3. And my first thought is this is going to be a very interesting looking rectangle. So I'm going to have confidence that my process works that I've been learning, and I'm going to go back and start with what I know. I'm going to line those up, and I'm going to line these up so that I have, maybe I'll go this way with them, my rectangle. I think that might work best. Let's see if I'm good with this. So I've got my 7 x's to go, and I'm going to put 3 of them there, and I've got 2 of them here, and my problem is I've got extra x's. So I guess my 3 doesn't go that way, but it needs to go this way. So let me move these 2 over. And look at that. Oh my gosh, it factored. I didn't think I could do that one. So my factors for this one happen to be x, 1, 2, 3, positive 3, 1x, 2x going across, so my 2x, and my positive 1. So I have x plus 3, 2x plus 1, or 2x plus 1. I like to put the one with the leading coefficient actually first. And x plus 3.
Okay, so when we did it with just one x squared term, it didn't really matter how you put the factors of the constant in the corner, but when we have an a that's greater than 1, the direction of the way you put those factors, those units, really does matter.
It really does, and I think using the area model helps them, and the tiles helps them to realize that what I need to be doing when I'm going back to put this together is that this 2 has to be multiplied by this 3, whether it's an inside or an outside, and then the 1 added to it. So it helps the students to see that those factors, versus just listing them down, have to be paired up in certain manners. Okay, well here we're going to try 3x squared minus 7x plus 6. Gosh, I was good with the 2x's almost, but maybe this 3x is more than I want to deal with. I'm going to 3x, the only way to make it a rectangle is to put them side by side, so let's start with that. And I've been finding out that with these 6's, it seems to be more likely that it's working when I do a 2 by 3. So let's see what happens, and I'm going to squeeze it in here and see what happens with this. Okay, since this 7 is a negative, all my x's are negative. And since my 6 is a positive, I know I need to fill in negatives here and negatives here, so I have a negative times a negative to give me a positive. I just don't think I'm going to be able to make this work. There seems to be not enough x's for this to happen. Okay, so let me try if I go this way. Hmm. I can't add 0 pairs because I can't add a positive to this. I guess I need to try it another way. Let me try this way. And I'm beginning to think Miss Kathy gave me one that can't be factored. Okay, this time I have 4x squared minus 9. So I only have x squares and the ones. And 4, for the first time I have something here that I don't have to just line up. It has another way of factoring, which is to make a square out of it itself. And I know something about 4. It is a perfect square number. So I'm going to start with the 4. I do think it's important for the students to be understanding that the reason we call them perfect square numbers is because if I take tiles of that number, I can make a square out of it. So I have a square that's 2 by 2. My area is 4. I think we need to point those out for the students. Now I know something about negative 9 as well, or 9 in and of itself. 9 is a perfect square as well. Because if I have 9 tiles that are I can make, or 9 somethings, I can make a square out of them. 3 by 3. Now, I have nothing in the middle for my x value. So in essence, I have plus a 0x inside there, which means I'm going to be adding some 0 pairs. So I'm going to add several 0 pairs to this. I'm going to start by adding ones that cover the entire side. So I have 1, 2, 0 pairs for that. And then I'm going to do that again. Because if I'm going to fill the rectangle, I might as well do the entire rectangle on that side at a time. And then I'm going to do it one more time. And I still have a square because I started with 2 perfect squares that I am filling in. So when I look at this side here, I have 2 x's and positive 3. And over here, I have 2 x's and a negative 3. I think it's important to take the model next and show what would happen if I had that 4x squared and a positive 9. If these all became positives down here. Because in order for them to be positives, I need to have either 2 negatives being multiplied together or 2 positives being multiplied together. I cannot multiply a negative and a positive and get a positive back. So none of my 0 square pairs will now work to complete my square here. And when I look at this now, there is nothing I can put in these things that keeps me at a 0 value in there. And we have something that's prime. And I think it's important to talk to the students about why this works and why this doesn't.